Welcome to Finance with Fairbanks, where real-world finance comes to life. Remember to like this video and subscribe to the channel. Hello and welcome. My name is Dr. Fairbanks, and in this video we are going to work through some capital budgeting calculation problems. Let's go ahead and begin. A project has the following cash flows. Assume a required rate of return of 12%. Calculate the net present value. Find the net present value. All we need is our cash flow worksheet. Once we use our cash flow worksheet, we just assign it to its appropriate values. For example, the time 0 cash flow becomes CF0. The time 1 or year 1 ending cash flow becomes C01. The frequency on all of these is going to be 1, of course. And then C02 will be the time 2 cash flow. C03 will be the time 3 cash flow, and C04 will be the time 4 cash flow. We'll then go over to our NPV worksheet and we'll enter in the value of 12 for our I, or our discount rate, and then we will simply compute the net present value. Let's use our financial calculators. Okay, so we'll go into the cash flow worksheet, we'll clear it out, second clear. We'll go ahead and enter in these values as they appear on the timeline. So 20,000 negative and enter. It's very important that our time 0 cash flow is a cash outflow. It is a capital expenditure for the firm. And the rest are hopefully positive cash inflows. That represents a conventional set of cash flows. Our time 1 or year 1 cash flow is $3,600. Our year 2 cash flow is $5,200. Our year 3 cash flow is $10,000. And last but not least, our year 4 cash flow is $12,000. We'll go ahead and go into the NPV worksheet now. We'll enter in a value of 12 and hit enter. We'll arrow down and hit compute. And what we find is that the net present value of this series of cash flows for this particular project is $2,103.71. A project has the following cash flows. It's actually identical to the prior problem. So all we're going to do now is we are going to calculate what is known as the payback period. To do this, we want to generate an extra column here. And I generally call this extra column the remaining balance. Because remember, with the payback period, what we're trying to do is we're trying to recover the initial cash flows, or initial cash flow to be specific. Now, we are violating time value of money. We are summing cash flows along a timeline, but we are simply trying to find how long it will take, regardless of our discount rate, to pay back our initial cash flow. So our remaining balance today is going to be $20,000. Notice that in 1 year's time, we will receive $3,600. So we're going to add the $3,600 to our remaining balance, and what we will find is that what is left over is $16,400. We move to the second year. We go ahead and add $5,200. And once again, we still need to recover $11,200. Moving forward one more year, and we find that we still need to recover $1,200. That's because we added the $10,000 there to our balance. And now when we add the remainder or the last cash flow in this project, the $12,000, what we find is that we have a positive remaining balance. Now what this tells me is that my payback period falls somewhere between the end of year 3 and the end of year 4. It cannot be less than 3, and it cannot be any greater than 4. So what I'll say is that my payback period, or PB, is simply equal to 3 plus something. That something is the remaining balance, the absolute value of that remaining balance divided by the next cash flow that will be received. So I take the 1,200 and I divide it by the 12,000, and what I find is that the payback period for this particular firm is 3.1 years on this project. Okay, in this problem, we are looking at the exact same set of cash flows, except for this time, we want to calculate what is known as the internal rate of return. Hopefully, you've already stored this information in your financial calculator. Again, the time zero cash flow is CF0, C01, C02, C03, and C04, respectively. You've plugged all of those in. And now when I go into my financial calculator, you can see this is the NPV that we found in the very first problem. I'm now going to click on my IRR button, which is just to the right of the NPV, and I'm simply going to hit compute. And what I find is that the internal rate of return, remember this is where the NPV is equal to 0, is 16%. A project has the following cash flows. Assuming a required rate of return of 12%, calculate the three versions of the modified internal rate of return using the reinvestment approach, the discount approach, and the combination approach. Now recall the three approaches. The discount approach brings all of the negative cash flows back to time 0 and leaves everything else the same. The reinvestment approach sends both all of the positive and negative cash flows to the end of the timeline. So that means the time 1, time 2, time 3 are all going to be sent to the end of year 4. And then the combination approach brings that negative cash flow back to time 0, but it sends all of the positive cash flows to the end of year 4. Now, the easiest thing to do with this is the first thing we're going to find the present value of this time 3 cash flow. So we'll do it over here. We'll find the present value of this time 3 cash flow. Now, obviously, we can use our time value of money input parameters, but I'm just going to use the mathematical formula here. So we will take 10,000 and we will simply divide it by 1.12 raised to the third. So I'm again trying to bring that back exactly 3 periods so that I can find the present value of this cash flow. It's needed so that we can do the discounting approach, and it's needed so that we can do the combination approach. Let's use our financial calculator. Again, you could use the time value money parameters if you wanted to. Obviously, N would be 3, IY would be 12. There would be no payment. The future value would be that 10,000, and you would find the value. But we'll just go ahead and use our mathematical equation, open parentheses, 1.12 raised to the third power. That's 3 years, bringing it back. And we find that the present value of this cash flow is $7,117.80. Okay, the other item that we are going to need with this in order to do these calculations, because we're trying to find these modified internal rates of return, is we are going to need a future value column. Now, we never shift the initial cash flow. That always remains the same, so we're not going to worry about that one. But what we are going to do is we're going to find the future value of the time 1, time 2, time 3, and time 4 cash flow. Well, the time 4 cash flow is really easy because that one is just itself. It's not being discounted. It's not being compounded. The value of $12,000 at the end of year 4 is $12,000. What we do need to do, however, is we need to send this $10,000 to the end of year 4. Notice that that is only 3 periods into the future. So the value here for this cash flow is going to be 10,000 times 1.12 raised to the third. For the 15,000, we only are going to move that 2 years, so it'll be 15,000 times 1.12 squared. And then the last one will be the negative 10,000 times 1.12. And so our future value, I'm going to go ahead and use a different color here. Our future value on this last one, or the time 3, is just simply going to be negative $11,200. I don't really need the calculator to do that one, but we'll check these other two with the financial calculator. So we need 10,000 times, open parentheses, 1.12 raised to the third. We find that that cash flow sent to the end of year 4 is $14,049.28. Then we'll go ahead and shift this 15,000 by multiplying it by 1.12 squared. And we see that the future value of that cash flow is $18,816. We'll go ahead and write that information in. Okay, now that we've done these extra calculations, which is really nice, we can now work on the different approaches. So I'm actually going to start with the discounting approach. I think, in my opinion, this is probably the only approach that makes the most sense. And what it does, recall, is it brings the negative cash flows to time zero and leaves everything else the same. If the firm knew in advance that they were going to have to pay this extra $10,000 at the end of year 3, they might stock it away today. That's kind of the idea with this discounting approach. So we're going to take this $22,000, we're going to add the present value of the $10,000 here, and what we find is that now our time zero cash flow is negative $29,117.80. And then we get the rest of the cash flows just remain the same. So 10,000, 15,000. Notice that this one becomes zero because we moved it to time zero. And then my last cash flow is 12,000. Okay, so we're setting up the cash flows. Now, in the second approach, which I would call the reinvestment approach, in this approach, recall that we're sending all of the cash flows to the future. So that means that my time zero cash flow remains the same at $22,000. We don't add anything to it. We are going to have zeros at the end of year 1, 2, and 3. And then at the end of year 4, what we're going to do is we're going to take the sum of the 14,04928, the 18,816, the 11,220, and the 12,000. And when we do this, what we find is we find that the time for cash flow is $33,665.28. Okay. Now we're moving into the combination approach, or approach number 3. This is what I would call MIRR 3. And remember that it sends the negative cash flows to time zero. So the first cash flow looks identical to the discounting approach. And we get zeros at time 1, time 2, and time 3. The key difference is that we're not going to add this negative $11,200 to the last cash flow because it's been sent to time 0. So now our combination approach cash flow is $44,865.28. The last step here is to use our financial calculator and find the IRR for all 4 of these sets of cash flows, and then we'll compare it to the required rate of return of 12% and determine whether or not we are going to accept or reject this project. All right, let's go into our cash flow worksheet. Let's clear it out. Again, we're just going to start with the original cash flows. That's negative $22,000 on the time 0 cash flow. $10,000 on the time 1, $15,000 on the time 2, negative $10,000 on the time 3, $12,000 on the time 4 cash flow. We'll go into IRR, don't need an I here, and just hit compute. And we find that the internal rate of return is 10.428%. Okay, we'll clear that out. Go into our cash flow worksheet again, clear it out, and now we'll do the discounting approach. So we'll put 29,117.8 or $29,117.80 negative, hit enter. I'm going to arrow down, type 10,000 and enter, arrow down, 15,000 and enter, arrow down, hit enter because C03 is 0. Now C04 is 12,000. We'll hit enter, go into IRR, hit compute, and we find that the internal rate of return, or more specifically, the modified internal rate of return using the discounting approach, is 10.95%. All right, we got to do this 2 more times now. Go into our cash flow worksheet, we'll clear it out. And for the reinvestment approach, or approach number 2, we're going to take the 22,000 negative for CF0. We're going to enter down to C01. We're going to type 0 and enter. We're going to put a frequency on that of 3 and enter. We're then going to arrow down and put $33,665.28 for my time for cash flow. We got away with that because we don't need to type the 3 zeros in. We just use the frequency key. So we'll go over to the IRR and hit compute. And what we find is that the internal rate of return using the reinvestment approach is 11.22%. All right, last time we'll clear this out. And now we're using the combination approach. So my time zero cash flow is a negative $29,117.80. Remember, we sent that one negative cash flow back to time zero. My C01 is 0 with a frequency of 3. I'm arrowing down to C02, which is really my end of year 4 cash flow. And I'm typing $44,865.28 and enter. I'm clicking on IRR and hitting compute. And I find that the internal rate of return using the combination approach, or MIRR3, is 11.41%. And I think the grand conclusion here is, given all of these internal rates of return, even with their modifications, we arrive at a value that is still less than the required rate of return. Which means we should reject this project. A project has the following cash flows. Assume a required rate of return of 12%. Calculate the profitability index, or bang for buck measure. Now, this is the original set of cash flows that we were working with when we didn't have an unconventional set with a sign change like we saw in the prior problem. However, to find the profitability index, or PI, what we're going to do is we're going to find the present value of the cash flows, of the future cash flows. And then we're going to simply divide that by the absolute value of the time zero cash flow. Now, once again, I think the easiest way to do this is to use your cash flow worksheet, but we're only going to focus on the non-time zero cash flows, or all of the cash flows except for the cash flow today, because we're trying to find the numerator. We're trying to find the present value of the expected future cash flows. And then we'll simply divide it by the $20,000 that is required in terms of capital expenditure today. Notice I'm ignoring the negative sign there. So we already know the denominator in this problem, and that is going to be $20,000. Again, I'm ignoring the negative sign because that would make this measure harder to interpret. We're going to go back into our cash flow worksheet, clear it out. We're not going to enter in the time zero cash flow, but we'll go ahead and enter in the rest of these. All right, now that we've entered in all of the cash flows, we'll simply go into our NPV worksheet. We'll enter 12 for I. We'll arrow down and hit compute. I know that that says NPV, but keep in mind that that is simply the present value of the expected future cash flows. This is something that we used in time value of money. It was very useful to find the present value of an uneven stream of cash flows. That becomes the numerator. So to find the answer, we're simply going to divide that by the $20,000 denominator, and we find that our profitability index is 1.105. Fair & Co. is evaluating two mutually exclusive projects. Assuming a required rate of return of 7%, calculate the following for each project: NPV, IRR, PB, and PI. Also calculate the crossover rate. We're going to do all of these calculations to help us decide whether or not we're going to accept or reject that particular project. We'll go ahead and start with project A. We'll go ahead and make a little table over here on the left-hand side. So we'll put NPV, because that's what we'll find first. Then we will find the IRR. Then we will find the profitability index. And last but not least, we will find the payback period for each project. And then after we do that, we will find the crossover rate and talk about what that ultimately means for interpretation. So let's go ahead and enter the cash flows for Project A into our cash flow worksheet. Okay, going into the worksheet, let's go ahead and clear this out. Let's enter these cash flows in. We have 100,000 negative and enter. We'll arrow down. We've got 50,000 for our end of year 1 cash flow. We have 40,000 for our year 2 cash flow. We have 18,000 twice for our year 3 and year 4 cash flow. Now I could use the frequency key and change it to 2, but this time, because it's only one more cash flow, I'll go ahead and enter it in for C04. So let's check it, and it looks good. Okay, we'll move over to our NPV. We have a discount rate of 7%, so we'll type 7 and enter. We'll arrow down and hit compute. And what we find is that the net present value of the first project is $10,091.99. I would probably just round that to $10,092. Okay, let's go over to our IRR and hit compute. We find that the internal rate of return on this project is 12.46%. That leaves us with one final metric that we can do right here in our financial calculator, and that happens to be the profitability index. Now for that, what we're going to do is we're going to jump into our cash flow worksheet. We're going to enter 0 for our time 0 cash flow and leave everything else the same. That's very key that we do that. We're then going to go into our NPV button, leave the discount rate, arrow down, and hit compute. Remember that that is representative of the present value of the expected future cash flows. That is the sum of the time 1, time 2, time 3, time 4 cash flow brought back to today in a single lump sum. And then we're simply going to divide that by the absolute value of our time 0 cash flow, which is $100,000. And we find that the profitability index here for this particular project is 1.1009. All right, let's do this again now for Project B. So we'll go into our cash flow worksheet, we'll clear it out, we'll go ahead and enter these in. So we'll take 120,000 negative, enter, arrow down to C01, and we'll put 25,000 for C01. Arrow down to C02, we'll put 24,000. Arrow down to C03. C03 is 45,000. And C04. Okay, looks good. Now we will go over to our NPV worksheet. Again, we'll type 7 and enter. We'll arrow down and hit compute. And what we find is that this project has an NPV of $6,834.13. We'll click over to the IRR and hit compute. And we see that this project has an internal rate of return of 9.13%. Now to find that profitability index, again, we're going to use our calculator. We'll go back to the cash flow worksheet. We'll make our time 0 cash flow 0, hit enter. Go back to the NPV worksheet, arrow down and recompute the net present value, and then simply divide that by the absolute value of the time 0 cash flow, so just $120,000. And what we find is that the profitability index for Project B is 1.057. All right, let's write all this information down that we've learned so far. Now, because these projects are mutually exclusive, we can only accept one. We cannot accept both. We could, in fact, reject both of these projects if they had negative NPVs. And just based on the NPV itself, we would definitely want to select Project A over Project B, regardless of what we get for the other metrics. Now, it just worked out this way that the IRR happened to be greater for Project A than it was for Project B. And so too was the profitability index at 1.1009 versus the 1.057. So those first three metrics all came out and said, look, except Project A, the NPV is better, the IRR is better, the profitability index is better. We do have one last item to calculate, and that is the payback period. So what we're going to do is we're going to do that remaining balance, but I'm not going to draw this on the slide. If you like, you can get out a piece of paper and you can do this with me. But what I'm going to do is I'm going to take this 100,000, I'm going to add 50. So I still need to recover 50. I'm then going to add 40. That means I need to recover 10. Well, my next cash flow is bigger than the 10 that I need to recover. So that tells me for project A that the payback period is somewhere between the end of year 2 and the end of year 3. So my number starts with a 2, and then it's just going to be 10 over 18. That's the 10,000 divided by the 18,000 that needs to happen there. So we get a payback period of 2.556. Now let's do this again with project B. So I add the 25,000. I need to recover 95. If you have a calculator, you can do this with me rather than trying to do it in your head. Then we're going to add another 24 to that 95. And we still need to recover 71. And then we're going to add another 45 to that. And we still need to recover 26. Well, thankfully, the next cash flow is bigger than that. It is possible that you work through these problems and they simply don't have a payback period. In this one, it does. So we know it's between 3 and 4. So it's going to start with the 3, and then they need to recover 26,000 at the end of year 3, and the next cash flow is 60. So we take that 26,000 divided by the 60,000, and we find that the payback period for project B is 3.433 years. Once again, project A looks superior to project B. Its payback period happens to be quicker than B's, but that's not always the case, and sometimes we get conflicting results, and when we get conflicting results, we always go back to the NPV to help us make the decision. But in this scenario, all of the metrics came out conclusively for project A. The last part of this problem asks us to find the crossover rate for these two mutually exclusive projects. What I'm going to do is I'm going to take the difference between the cash flows for project B and the cash flows for project A. But honestly, you could do A minus B and you would still get the same answer. So if we take 120,000, we subtract off 100,000, we're left with a negative 20,000. If we take 25,000 minus 50,000, we get another negative $25,000. If we take 24,000 minus 40,000, we get a negative $16,000. And if I take 45,000 minus 18,000, we get a positive $27,000. And last but not least, if we take the 60,000 minus the 18,000, we get $42,000. Now to find the crossover rate, all we're going to do is plug this into our cash flow worksheet, and then we will solve for the internal rate of return. Let's plug these numbers into our cash flow worksheet. So we'll click on the cash flow worksheet. For our time 0 cash flow, we will enter $20,000 and hit enter, negative of course. Then for our time 1 cash flow, we'll hit negative $25,000 and enter. For our time 2 cash flow, we'll enter $16,000 negative. And for our time 3, we'll put $27,000. And for our time 4, we'll put $42,000. Now it appears I forgot to clear my cash flow worksheet, which means I need to make sure that there are no additional cash flows along this timeline. So that looks good. Okay, we'll go into our IRR button. We will compute the internal rate of return, and we find that the internal rate of return on this project is 4.701. Now, it's not really the internal rate of return on a project per se, but it's the internal rate of return on the differential between the two projects, which does represent the crossover rate. Now, what we can learn from that information is that we're going to have two profiles. We can build these in Excel, of course, but we're going to have a profile for project B, and then we're going to have a profile for project A. And I drew this knowing the information that I have over here on the left-hand side of the screen. I know that the internal rate of return for project A is higher than the internal rate of return than project B, because we know A is 12.46%, we know B is 9.13%. our profiles have to look something like this, and then we just found that crossover point at 4.701%. Now, the information that we can get from this, because we know the IRR of A is greater than the IRR of B, what I can tell you is that from 0 to 4.701%, we're going to accept project B and reject project A. Also, from 4.701% all the way to the internal rate of return for project A at 12.46%, we're going to accept project A, which is what we did earlier because our discount rate was 7%, and we're going to reject project B. And after, or anything greater than 12.46%, we're going to reject both projects. King Cash Co. is considering a new project that requires an initial capital expenditure of $35,000. The project will generate the following after-tax cash flows over the next 5 years, $8,000, $9,000, $10,500, $8,000, $10,000 respectively. Assuming a required rate of return of 12%, calculate the payback period. Once again, the easiest way to tackle these problems when they don't give you the table of cash flows is simply build the table of cash flows. So that's what we'll do. We know we've got years 0, 1, 2, 3, 4, and 5. We were given the cash flows. We can write those down. It's very, very important that you recognize that the initial capital expenditure is a cash outflow. Thus, we need to put the negative sign in front of it. So we have the 8,000, the 9,000, the 10,500, the 8,000, followed by the 10,000. Just like we did in the prior problem, I'm going to go ahead and calculate the remaining balance column. I think that's really useful. A little bit difficult to do when you have multiple projects and not enough space. So obviously we still need to recover the 35,000 today. We're going to receive the 8,000, so we're going to add 8,000 to that. That's going to leave 27,000. We're then going to add the 9,000 that we receive at the end of year 2. That's going to leave us with 18,000 in a remaining balance at the end of year 2. We're then going to add that 10,500, and what we see is that our remaining balance would be $7,500, and the next cash flow is larger. What that tells me, again, is the payback period is somewhere between the end of year 3 and the end of year 4. So my number starts with a 3. Then I take the absolute value of the remaining balance and I divide it by that next cash flow of 8,000. And what I find is that the payback period on this project is 3.9375 years. All right, folks, last question. Calculate the net present value of a project that has an initial cost of $50,000 and produces $10,000 in after-tax cash flows for the next 8 years. Assume a required rate of return of 10%. Now, we could draw the timeline. We could build that table just like we did in the prior problem. However, a particular problem is actually much easier if we recognize the time value of money aspect of it. First of all, we can recognize that our time zero cash flow, or CF0, is in fact negative $50,000. But this second part of the information is telling us that the produced cash flows on an after-tax basis is going to be an ordinary annuity. The firm expects to receive $10,000 at the end of every year for the next 8 years. Well, in this case, we will go ahead and just use our time value of money input parameters. We'll solve for the present value of that annuity. Now I'm going to put a negative sign in front of that $10,000. That way, when we calculate the present value, it will be positive because these are positive cash inflows for the firm. So we don't want to confuse that if it flips the sign on us. The discount rate is 10% and the number of periods is 8. Now once we get this present value, to find the NPV, what we are going to do is we're simply going to take that CF0, the negative 50,000, and we're going to add back the present value of the future cash flows. that means that our NPV is going to equal the $50,000 plus whatever that present value number happens to be. That's why I wanted to put that negative sign in front of the payment, because I didn't want the sign to flip, okay? Because then I'd be adding a negative to a negative, and the answer would obviously be incorrect because the future cash flows are actually positive. All right, let's use our input parameters. So 8 for N, 10 for IY, 10,000 negative for the payment, and 0 for the future value. Compute PV. And what we find is that the present value of the expected future cash flows, because it is an ordinary annuity, is $53,349.26. Now, to finish this problem, all we're going to do is we're going to add negative 50,000 to that number. And what we find is that the net present value in this example is $3,349.26. All right, folks, that concludes this video. Remember to smash that like button and subscribe to the channel. Until next time, goodbye.